Hi guys, good evening everyone. Welcome back to the AS Math Hub. Today we begin with the practical number 4. In this we'll cover about mathematical symbols, Greek letters, calligraphic letters, log-like functions, arrays, the array environment, vertical alignment. We'll study about delimiters and multiline formulas. But before that, please study this definition, a package. Till now we have prepared LaTeX document before without specifying any kind of packages. But from now onwards we will be specifying certain packages, and most commonly used package is AMS Math. Another one is PStrix and PST plot, color for the colors, while if you need to use some colors, AMS sim for using certain symbols, and various other packages are also there. So we define package like an add-on or a plugin to the LaTeX that provides some extra commands, environments or formatting options. So basically the LaTeX gives you a structure and it provides you with basic functions, basic commands and basic environments. But if you need to use certain particular type of mathematical commands, you basically use AMS Math. That is the most commonly used in the mathematics environment. Mathematics that consist of mathematics commands. PStrix for the PStrix, that is the image generation tools. PStrix includes the PS circle, PS picture and all those commands. So package is like that. Further, we study about mathematical symbol. We all know less than equal to, greater than equal to. We commonly use them in our mathematical writing. So we have certain command, \LE for less than equal to, \GE for greater than equal to, NEQ for not equal to, IN for belongs to, subset, cup for the union if you need to specify a union of two sets or something like that, cap for the intersection. Greek letters we have already done the previous practical. In detail we have done both the upper cases and the lower cases. I have told you. I'll provide these notes, I'll provide the soft copy in the very last video of this series. That is the 12th lecture, maybe 10th or 12th lecture, that would be coming in the following lectures. Further, the calligraphic letters, we use the Math Cal A. Have you seen that stylish real number R that is represented? So we use the Math Cal A to represent those kind of calligraphic letters. So calligraphic letters are decorative uppercases letters commonly used in representation of sets, spaces, families of functions and spatial mathematical objects. Fine. Further, we have log-like functions. Log-like function may include log x, we all know log x, sin x, cos x, then limiting function. The limiting function, limiting x tending to 0 for the limiting function. Then we have arrays. So we use array environment. Array environment is used to arrange mathematical expressions in rows or columns inside a mathematical mode. It is similar to matrix but offers more flexibility in formatting. For example, here I have used CC. So this CC will make two columns and this AND will separate the two columns accordingly as 1, 2, and this 2 backslashes indicate that there is a line break. Further 3, 4, and both these columns are separated by this AND. So I believe you must be remembering while inserting symbols I have used the calling function. For maybe for printing AND we use \AND to print AND. Because it has certain LaTeX feature that it had been used in the array environment for the alignment. For the alignment in the mathematical rows or mathematical columns as we want it. So that is the use of AND. Percentage use also we know. The percentage is used to demonstrate the comments, and dollar also we have used previously. The dollar is for the mathematical commands. While inserting mathematics we use dollar commands. So that is why whenever we need to print these symbols we use the calling function, that is the backslash and the symbol. So backslash percentage, backslash dollar, that is how we print the symbols. Fine. So Herein we have used all the three symbols. Further, we have the array environment. We use LCR. Basically, this is for the three columns. So LCR is left aligned, centered, and the right aligned. So basically, it would create three columns. One would be left aligned, the another would be centered, and another would be, the third one would be right aligned. So LCR will create a three column matrix, say, or a table, say. So three column alignment. Further, for the vertical alignment, we can use the align environment. We have been used the array environment. Now we will be using the align environment. So vertical alignment is achieved using environments such as align. So this environment aligns multiple equation at selected symbols. So if I need to align something, I'll use AND. For example, A plus B equal to C, I have equation, and another equation, say suppose X is not there, Y equal to Z, and both of these equations are aligned with the equal to sign. So if I need to align both the equation with the equality, I'll put the AND with that symbol. I'll put the AND adjacent to that symbol. We'll see all this example very soon. Then we have delimiters. I told you this in the very last class, that is, while introducing the brackets, while introducing the the circle braces, the parenthesis or the square bracket, we can use the delimiters. I mistakenly said about them as the indentation in the previous video, but it was delimiters I wanted to say. So the delimiters are symbols such as parenthesis, brackets, braces, or vertical bars. They are used to group mathematical expressions, and LaTeX can automatically adjust their size using the \left, \right delimiters. So we have \left. This is a parenthesis, the circle bracket, I would say. The parenthesis, the curly braces we can also insert, and the square brackets also we can insert. Then we have multi-line formulas. We can use the align environment for the multi-line formulas. Fine. Then we will try this example at last. Okay, so let us try to run all these codes in a LaTeX document. I hope till now you all guys must be knowing how to create the LaTeX document. So first we create a new file using the Ctrl+N key, and then we save it in a folder. Okay, so today is 26th June 2026. We first specify our document class, say article only, and document class. Here we can specify the package we want to use in our document. Suppose I am using, because I have to use the align environment, all those environment that we would be using in this practical, they come from AMS math environment. We use package AMS math. So this is a package that involves all the mathematical commands. Then we have the document environment. Okay, so package, I have told you what is the use of package. Then we can insert mathematical symbols. Less than equal to, greater than equal to, say 2 is less than equals to 4. 8 is greater than equals to 6. What is the mistake? That's the dollar command. Either we can use the display operator also as well, since we are having two equations, right? So we can use the display operators as well. I think there is an error while printing these two commands. We are using the same display operator. So either we can separate them like this, and then we'll get our result separately. Okay, fine. Similarly, we have not equal to, so that is, we can use a dollar command as well. So dollar 8 is not equal to 4. Here, fine. Since I have used the display operator for these two expressions, so they have been arranged in the center, and the last one that I have printed using the dollar, that had been left indented. So this is also a symbol. Then we have approximately in command, so we can use the in command like this. Say anything, square root 2 belongs to, that is in, mathcal r. So this will display the stylish real number. Let's run this. Fine. Root 2 belongs to real number. Similarly, we can use the cup command for the union and the cap command for the intersection. Greek letters we have already done. Calligraphic letters I have just showed you. I have just shown you real number. So mathcal a. What command we use? Mathcal a. Similarly, say mathcal a. So this will display it in a stylish manner. Observe it. Fine. I hope this would be clear. Then we have log-like function. How to introduce them? Log-like function, we can do it like backslash sin x. Then we need a dollar. Similarly, cos x, and so on. Suppose I need to insert a limit. So backslash limit. For this we have 2, so this will create an arrow x to 0, and this will go in the subscripts. So limit x tends to 0 of x square. Limit x tends to 0 of x square. So backslash 2 is for this arrow that we have the limit. Then array environment. The array environment is used to arrange mathematical expressions. That is begin array. We can use here either CC or LCR, or even CC LCR for 5 rows, 5 columns I should say. CC say sin x, cos x, cos x, tan x. Clear? If I need to insert, say, this one, so I got a line. Suppose I need to insert a table here, so we can use this mod operation. So this will create a table of three lines for the two columns. And suppose I need to insert the horizontal line as well, so I have the h line command. After every this particular line, I can use the h line command to end or to insert a horizontal line. So this will create a table for me. Okay, line 24. Just a minute. Okay, so we can insert a horizontal line like this. Similarly, we have array environment. We can use the LCR. Suppose I need to insert one more column. So oh, I hope now it is clear. Fine. If I need to insert a horizontal line at the last also, I can create a line break here and then insert a horizontal line. So this is array environment. Then vertical alignment. For vertical alignment, I can use the align environment. We'll use it shortly while printing this command. Then we have delimiters. Suppose I want to write this thing only in a matrix type of style. So I'll just remove these horizontal and vertical lines and insert a delimiter accordingly. Fine. So that's how we can insert a delimiter and to introduce it like a matrix, to show it like a matrix. For the multi-line formulas also we can use the align environment similarly. So let us print this one. Let us print this output. We have tan a plus b equals to tan of a plus b plus c. Then we split the formula for a plus b and c. Then we can again split the formula for a plus b. So we have this expansion like this. So let us try to write this code. Either we can use a display operator or we can use the dollar commands. So it's absolutely fine how we do it. Then we have tan of. So I have already told you that we need not insert the delimiter all the time. We can simply insert the parenthesis whenever required. So the latex, in most of the cases, latex never counters an error for this problem. So tan a plus b plus c equals to tan of a plus b plus c. I think that's all we have done here. Fine. Then tan of a plus b plus tan of c by 1 minus tan of a plus b tan Okay, so we'll print this result. Then we have tan a plus b plus c equal to tan of a plus b plus c. Now the second line, observe that the second line is aligned with the equality operator. So for alignment, I'll use the align environment here. So backslash begin align and backslash end align. So we'll use the and equal to, and the second line is tan a plus b plus tan c by. So I need a fraction here, so I'll use a backslash frac command. Fine. So backslash frac, the first bracket for the numerator and the second bracket is for the denominator. So on the numerator I have tan a plus b plus tan c by 1 minus tan a plus b into tan c. So we'll use the begin and end align environment. Let us remove the display operator first, and we'll use the dollar operations if required, but it need not be required for dollar or display operator now. So we can print it like this only. If it would be a mathematical input, then we needed the display or the dollar operator. So let us write the another line. Then I have and equal to, then I open tan a plus b and tan a plus b here. What we'll get? Tan a plus tan b plus tan c minus tan a tan b tan c in the numerator. So we simply will use the frac command. So tan a plus tan b plus tan c minus tan a tan b tan c. So tan a tan b tan c, and the denominator we have 1 minus tan a tan b minus tan b tan c minus tan c tan a. So 1 minus tan a tan b minus tan b tan c minus tan c tan. If I needed a line break, I need to print a line break over here, then I'll get this alignment. Fine. How to print this code? So by default the align tab will give the automatic numbering. In case I need not require the automatic numbering, I can use the environment align star. So align star will not number it. Fine. So that's all about practical number 4. I hope this would be clear to you all. Thank you all for joining. Bye bye.